Okay, so here we are with an actual PowerPoint. If you don't know what that is, don't worry about it. It's just pictures that are shown by grown-ups when they talk about a particular topic. So this is from a website that's called FreePic, but they have a program or a level where you actually pay for the figures, which is higher resolution. Hopefully I'm not stealing, because we want to use material we find on the internet, but we want to always do the right thing. We do not want to steal books and figures and images and so on. But since I teach a lot of courses, I cannot keep paying for these simple figures, and I always don't have the time to make it myself. This figure, on the other hand, is very useful for starting a discussion on energy that is coming to Earth and the energy that is going out of the Earth to space. Why is it important to look at these? Because that's the energy balance. What do you mean? So let's say your father or mother is working and getting a certain amount of salary per month, and they spend that money on food and rent, or buying a car and sending you to school, tuition, everything. So the balance is basically about the salary or the income and the expenditure. Unless these are balanced, if you keep on earning more than you spend, you will keep accumulating money in the bank, which could be good. Or if you spend more than you earn, then you keep getting into debt, or you will have less and less money, and in fact may need to borrow money to manage, and so on, right? So that's why energy balance is important, and we'll see slowly that that's what creates the weather and climate that we are talking about, especially winds and of course winds bring other processes. They form clouds, they lift water from land or oceans, lakes, and so on, and produce clouds, and clouds move around with the winds, they produce rain. So everywhere there is energy is being moved around. Why does it have to move around? That's the key question. So let's come back to energy. So here is a pot sitting on a stove, and these flames here shown, by just looking at them that that's hot, right? That fire. So if you go near it, you will feel the heat, and be very careful. Don't do any crazy experiments unless you are with an adult. And you probably also know that this kettle is warm, as it is being heated by the fire, and it's producing steam here, and then you are putting things into it like some Maggi noodles or pasta or vegetables, fish, meat, whatever you eat, right? So the energy is getting transferred to the pot, and the pot is transferring the energy to the water, and the water is transferring the energy to the things that are floating in the water. Could be milk and tea leaves and so on and so forth. But the main point is, this is hot and you can see it, right? You already probably learned, based on depending on which class or standard you are in, that sun's energy is coming in a visible band. So sun produces energy, lots of it, with nuclear fusion happening inside. Let's not worry about nuclear fusion right now, but if you want, you can follow up on my other podcast. Basically, hydrogen molecules are fusing to form helium molecules, and it's an uncontrolled reaction that keeps producing energy, and sun's energy is going out in every direction, and we are receiving that energy. That energy that sun produces has lots of wavelengths, electromagnetic spectrum it's called in technical terms. Basically, it will have some energy at very short wavelengths and some energy at very long wavelengths. When it's at very short wavelength, it will have higher energy, so something like ultraviolet rays. And you may already have heard that ultraviolet rays can burn your skin and damage your health and so on and so forth. And you may have already learned that a lot of this very strong ultraviolet energy gets trapped in the upper atmosphere. So without going into all those details, imagine that all the energy from the sun is coming at visible wavelengths, which means, wavelength is what? You throw a little stone in the pond and it produces waves, and you have, rising water and sinking water. So that is one wavelength. So without getting into too much detail, how quickly those waves move and how long is the uh, envelope of one rising water and one sinking water is a wavelength, and how fast it travels depends on its period, and so on and so forth. Keeping all that in mind, let's just call this visible band because we can see it, and a lot of the life has evolved to see at this visible band. And the pot is getting heated. If you cannot see it, but if you go near and put your hand, you will feel the heat. Again, don't do this on your own, do it with an adult. And you may also know that the pot heats relatively fast because something called heat capacity matters. Every object has a heat capacity. If you are walking outside, you know that soil and grass will not be as hot as the road or a metal or a rock, because anything that has higher heat capacity warms slowly and also cools slowly. Anything that has low heat capacity warms fast and cools fast. So the pot has low heat capacity, so it quickly warms, transfers the energy to the water, and you probably already intuitively know that water has a high heat capacity relative to the pot, the metal. So it heats slowly and it cools slowly. What does it mean? If you turn off the flame, the water inside will remain warm for a long time, whereas the pot may begin to will cool down relatively fast. It will remain warm because the water inside is warm, but the water will take a long time to cool down. And this matters because the energy that is coming in is heating everything. It is heating the oceans, it is heating the land, it is trying to heat the vegetation, bare soil, cities, buildings, everything. Whatever has high heat capacity will warm fast relatively, and the ocean, which has got deep waters, will warm slowly and cool slowly. A lake will warm slowly and cool slowly, but lake may not be very deep, so it will warm faster than, let's say, the ocean, which is very deep, and will cool faster than the ocean. All these things matter because how the energy coming in from the sun in the visible wavelength gets distributed or stored. So if sun comes up and sun sets, then the energy is going into the ocean. Even though sun sets, energy remains in the ocean because it has warmed up during the day and it doesn't cool down completely overnight. That means next day it will get heated again. So it can begin to accumulate heat, whereas land may warm fast and may cool down during the day. And you can imagine that land is not land because you may have cities where you have lots of roads and pavements and buildings, as opposed to rural area where you have a lot of soils and vegetation and agriculture, and the people are spraying water for irrigating the crops and so on and so forth. So all these things matter. Okay, that's in a crude sense the energy that is coming in and energy that is going out. So what is the similarity between the pot not looking hot but being hot if you go near? That's the thermal energy, or it's in the long wavelengths, much longer wavelengths than this sun's energy, which means we are not able to see it, but many animals see it because they are hunting at night, right? If you look at cats, many times their eyes glow in the dark because they can see in the longer wavelengths. Tigers, there are many animals which can do that. So this long wavelength is what is being created when everything heats up, and that energy is going out. How much of it can go out to space and how much is actually trapped by whatever is in the atmosphere above the land and ocean will determine how much of the energy that is coming from the sun is actually being lost and how much is actually being trapped. This is like the salary coming in and you are not spending everything. As we said, if you don't spend all the money, you will keep accumulating. So if you don't send out all the energy, you will keep accumulating the energy, which means it will begin to warm things. Okay, so we have to understand what are the gases in the atmosphere that allow the energy to go out and what are the gases that actually don't allow the energy to go out. What is this energy? Long wavelengths. You can call it also thermal energy or infrared energy. Your body is emitting infrared energy, right? If your mother hugs you, you feel the warmth. Or if you use a blanket, you can trap your own body's heat and create warmth. And this is why we use blankets in the winter when it's cold, because we can use our own body's thermal energy, trap it and produce heat, which is what Earth's greenhouse gases do. So we'll learn what greenhouse gases are and how the energy gets trapped and so on. So we'll use this figure again and we'll just put a lid on it and try to explain what we mean by that. Okay, so we'll come back and do that. Each time I'll try to keep the podcast to 10 to 15 minutes. This is already about 11 and a half minutes. Attention span tends to be about 7 to 15 minutes, so let's stay in that range. Okay, so I hope it's clear. Let's come back and continue a bit more on energy balance.